This is video 3.6, and the goal of this video is to be able to graph an inequality.
So the first thing is, what does that mean when it asks us to graph y is less than or equal to 3x plus 1? So once again, what does this mean? This means that they want you to describe all solutions, but the solutions now are a pair of points. So what points will work in this inequality? If I plugged in for x and y, which ones would work? That's what a graph of a line means as well. That's a collection of points that all work in a rule. Okay, we want the same thing here. So it's all the points, x comma y, that work in the inequality. Okay, so it's a bunch of points. That's why you've probably seen your teacher shading things in if you've seen these problems before. So let's talk about the steps to doing this. So when we're solving and trying to figure out what solutions are, step number one is we have to decide, is it a dashed line? And what I mean by that is a dashed line like this, or a solid line. And that's just our normal line. Okay? Once again, this is very similar to solving inequalities. It all depends on the symbol in the original inequality. See that it's less than or equal to? So once again, that equal to says include the line, is what that's saying. That it can be equal to the line y equals 3x plus 1. So in this case, I'm going to use this guy right here. Okay? So if it's less than or equal to, I'm going to use a solid line. I need to know this before I start graphing because I don't want to accidentally make it solid when I need to make it dashed. Okay, so we'll see an example where we're going to make it dashed so you know how to do that one as well. So now I know it's a solid line. The second step is to graph the line. So we can do this. This is why we learned how to graph these lines, so we can solve these real-life problems involving inequalities. So let's see. We're going to go and we're going to graph the line y equals 3x plus 1. Remember, the plus 1 is my y-intercept, so I'm going to go up to 1. And the 3 is my slope. And when I have a slope that's a whole number, I think of it as 3 over 1. That's my rise and my run. So I'm going to start at 1, and I'm going to rise 3, and go over 1. Rise 3, and go over 1. Okay, I'm going to try and graph a couple off to this direction as well. So I'm going to go back 3, down 3, and then back 1. So I have a nice solid line. Okay, this one is a nice solid line. So that solid line is some of the points that satisfy this inequality because of that equals, because it could have been equal. It was less than or equal to 3x plus 1. But I also need to figure out if there's more solutions. So once again, just like with graph solving inequalities, we check one point to decide where to shade. So I'm going to check one point. Once again, the best point to check, my favorite, is 0, 0. So it's any point in the graph. It could be way over here. I don't know what that is. It's a big point way over to the right and up 2. I could check this point right here, which is at 2, 0. But if I check 0, 0, I notice it's not on the line. It's to the right of the line. If I check 0, 0, I'm just quick with calculating with 0, 0. So what I'm going to do is plug in 0, 0 into my original inequality. So remember, our original inequality was y is less than or equal to 3x plus 1. So now I'm going to plug in 0 for x and 0 for y. So I'm going to have 0 less than or equal to 3 times 0 plus 1. So I plugged in 0, 0, and I'm going to check if this is a true statement. So let's see, the left side is just 0. I'm checking if it's less than or equal to, let's see, this will be 0, 3 times 0, plus 1 is 1. 0 is nice because it's easy to multiply by 0. So let's see. I look at this statement and I decide if it's true. Is 0 less than or equal to 1? Yes, it's true. So that means 0, 0 is a solution. And the good news is, since 0, 0 is a solution and it's on the right-hand side, that means that everything on this right-hand side is a solution. Everything over here. If I plugged in 2, 0, I would get a solution. If I plugged in this original black point that I have right here, it should work in the inequality. Everything on the right-hand side is a solution. So what we do is we shade it in to show that every point over here is a solution. Okay? Shade it in to show that every point over there is a solution. And then you're done. There's your solution set. All of these points to the right of the line. And the line, because it could be equal to the line. So that's the steps. Graph it after deciding if it's dashed or solid, then check one point to decide where to shade. Remember, if the point doesn't work, then you shade on the other side of the line. Let's take a look at the second problem that's on your worksheet. So second problem, y is greater than or equal to negative 2x plus 3. Okay, so once again, we have to decide, is it dashed or solid? So dashed or solid. Remember, it's solid if it can be equal to. It's dashed if it can't, if it's purely less than or greater than. And solid if it's greater than or equal to or less than or equal to. So I look at my symbol and I see it's greater than or equal to, so that tells me that it is going to be a solid line. So I've got my line figured out. Now I'm going to graph the line. So we're graphing the line just like we knew how from past chapters. So I'm going to start up at 3. And I'm going to have a slope of negative 2, which means negative 2 over 1. So I'm going to go down 2 over 1. Down 2 over 1. Down 2 over 1. I'm going to make a nice complete graph here. I'm going to do the same thing. I'm going to go backwards 1, up 2, backwards and up. Going back in time. I have a nice line, and I'm going to connect it with a straight, solid line. Okay? So now I'm going to test a point. So I graphed the line, now I'm going to check a point. Remember, 0, 0 is a good one to test. You can't always test it, but why not when you can? So we're going to plug it into our inequality. So we go back to our inequality, and we're testing if 0, 0 works. So 0, 0, take a look at your graph. 0, 0 is to the left, right over here, and we're going to see if 0, 0 is a solution. So let's see, 0 greater than or equal to. Negative 2 times 0 is 0 plus 3. So we get the following statement. Is this true? So let's see, this says 0 greater than or equal to 3. Well, that's not true. So that means that 0, 0 is not a solution. So this red point is not a solution. So I'm going to shade on the other side of the red point. Because 0, 0 was not a solution. Okay? And you're done with the graph. So graph the line after deciding solid or dashed, then check a point to decide where to shade. If you want to be extremely sure, you could click another point over here, and this is 3, 0. 3, 0 should work. So let's test it. 0 for y, negative 2 times 3 plus 3. We're plugging in 0, 3. And I see that it is going to work because I'm going to get 0 greater than or equal to negative 3. And that is true. So that green point that was in my shaded area does work. So it appears that I shaded the correct side. So you can be extra sure by plugging in 2 points, one on each side. One side should work, one side should not. So that's how we graph inequalities. Your job is to graph the next set of inequalities. Make sure you're asking your teacher if you get stuck, and checking your answers with your teacher so that you know if you're doing it correctly. So good luck, and remember these 3 steps to solving an inequality.